So this is a beaker filled with 600 milliliters of water. So 600 milliliters, if you look very closely, it is right there. Okay, that's 650, that's 600, and then that's 1,000 cc's, which really just means another unit for milliliters, cubic centimeters. So that's our water source. Now, we're gonna label our temperatures. So our beaker, we're gonna have one that's 50 mLs, one that's 100 mLs, one's at 250 mLs, and one that's 500 mLs. Temperatures are generally cooler in the morning, so try to follow the story below to better understand how relative humidity works. So I'm gonna set up my beakers. So as you can see, my beakers are a 50 ml beaker that is 50 degrees Fahrenheit, a 100 ml beaker that is 60 degrees Fahrenheit, a 250 ml beaker that is 70 degrees Fahrenheit, and a 500 ml beaker that is 80 degrees Fahrenheit. Notice that the beakers are different sizes. So if you look at page 6, we are on part 4. So question 4, or part 4 procedure, says temperatures are generally cooler in the morning, so try to follow the story below to better understand how relative humidity works. At 8 a.m. in the morning, the air temperature is 50 degrees Fahrenheit. There is dew on the lawn, so you know that the air is holding as much water vapor as possible. Fill the 50 degree beaker with water. The water represents the amount of water vapor in the atmosphere. So remember that our 50 ml beaker is going to have 50 degrees Fahrenheit. So 50 mLs is how much is going to go into my first beaker. So here's my first beaker, and you can see that it's labeled 40 mLs. So we're just going to pour slightly to the 50 ml line. So now you can see that we have 50 mLs in our 50 degree beaker. So what percentage is it fill if it can hold 50 mLs and we just poured 50 in? 50 divided by 50 times 100 is 100%. At 10 a.m. the temperature is now 60 degrees Fahrenheit. So we're upping our beaker to the 100 milliliter beaker, or 60 degrees Fahrenheit. You notice that there's no longer dew on the lawn. Take the water from the 50 degree beaker and pour it into the 60 degree Fahrenheit beaker. So now we have our 100 milliliter beaker. That's what it can hold, 100 mLs. I'm gonna take the 50 that this one can hold and pour it in there. So you can see that it's filled up to that 50 line. So how many milliliters of water do we just pour in? So you're gonna fill that out. And then how many milliliters of water can the 60 degree Fahrenheit beaker hold? So it can hold this amount, and we poured it right there. So go ahead and fill in part 6. And now you can calculate relative humidity. So relative humidity is the water in the beaker, how much is actually in there. So we poured 50 mLs in, right? We poured the 50 ml from our 50 beaker, divided by how much that beaker can hold. That beaker could hold that amount. And then you're gonna multiply by 100. So you're gonna figure out what the percentage of the water is in the beaker, and then what happened to the relative humidity as our temperature increased. Did it go up or did it go down? Now we're at noon. So at noon, we're working with our 70 degree Fahrenheit beaker. So now the sun is higher in the sky, so our temperature is getting warmer. And we're gonna take the water from the 60 degree Fahrenheit, which is 50 mLs, that we put into our 100 ml beaker. And now what we're going to do is we're gonna pour it into our 70 degree Fahrenheit beaker. You can see we're right there up to that 50 ml line. So what is the percentage of water in the beaker? So you're gonna calculate if our beaker can hold 250, but there's only 50 in, you're gonna calculate that percent. And you're gonna answer what happened to the relative humidity as the temperature increased. Did the percent go up or down? As the temperatures increase, what happens to the amount of evaporation that's occurring? So when things are hotter, think about when you're outside on a hot summer day, what happens to the temperature? What happens to the water that's on your body? Using the water in the 100 milliliter beaker, so we have this water, pour an additional 100 milliliters of water into the 70 degree Fahrenheit cup. So I just poured 100 mLs in. We were at 50, now we're at 150, so that's an additional 100 ml. Now we're gonna calculate what is the percentage of water in the 70 degree Fahrenheit beaker. So remember that as water is heated, more water is going to evaporate. So the day got hotter, it went from 50 to 60 to 70, so now there's more water in the atmosphere. So you're going to calculate what happens to the air and the amount of water vapor and the percentage of relative humidity. At 2 p.m., so I'm on question 8, the temperature is now 80 degrees Fahrenheit. Take the water from the 70-degree beaker and pour it into the 80-degree beaker. So we have now 150 mLs total. I'm going to pour it into my 500 ml beaker. So you can see right there, we're up to 150 mLs in our 80-degree Fahrenheit beaker. And now you're going to calculate the percentage relative humidity. What happened to the relative humidity as the temperature increased? Remember that as temperature increases, the amount of water vapor evaporating increases, so the amount of water vapor will also increase. So now we're going to pour an additional 200 mLs of water into the beaker to represent the amount of added water vapor. We just poured 200 mLs into our beaker, so we went from 150 to 250. And now at 250, you can see we're going to now calculate the new percentage. So we could hold 500 mLs right here, but we have 250 in our beaker. I'm sorry, we have 350 in our beaker. Part 9, at 4 p.m. a cold front came through and the temperature dropped to 70 Fahrenheit. Take the water from the 80-degree beaker and try to pour it into the 70-degree beaker. So we're going to take all of this from our 80-degree beaker and we're going to try to pour it into our 70-degree beaker. Oh no! I'll put this there. What's happening? So you can even see I got my little puddle going over there. So describe what happened and what do you think this represents?